This is Chris. Today we're going to take a look at extending the ZXN compiler, adding a repeat loop construct. For those of you that saw the previous video where I introduced some of the concepts of the language, I showed that we have for loops and while loops. Loops, not like that. And today we're going to add repeat loops. Right? If you're not familiar with repeat loops, it looks something like this. And the variable I equals 0. We will repeat the println I, increment I each iteration until I is 10. So how will we go about this? First of all, today the compiler does not have any concept of repeat or until as tokens, so we'll have to add new token support. And then we'll obviously have to build up the syntax tree, the AST, abstract syntax tree, that represents a repeat statement, and then get into generating code for it. But we can do a little trick here, because we already have a while loop, and while loop is very similar to a repeat. In fact, we could transform that repeat that we see there into a while loop, doing the following. We can say while true, so repeat forever, this exact same body. Now, obviously, if we ended at this point, that would be incorrect because the loop would loop forever. So we need to have something that will break us out of this loop, and that would be if I is equal to 10, it will break out of the loop. This is very similar to our repeat. Basically, this line corresponds to the repeat. And this block here corresponds to the until I equals 10 portion. So if we can generate an AST for a while loop, it looks like this after we've transformed the repeat, then we don't have to worry about code generation. Let's see how far we get. So let's start with adding the new tokens. We'll go to the compiler. We will go to our tokens, and let's find out. We can add it in here at the for token. This is just a big enum of all the types of tokens that are support. And we'll add repeat and until as tokens. Now that we have the token types, we also need to tell the parser what keywords in the code represent those tokens. So here I have a table. So basically tells the parser whenever I see the word repeat in the code, I'm going to generate a token type repeat. And we'll do the same thing for until. When our parser encounters the until word in the code, it will generate a token type until. Okay, so our token sorted. Now we need to actually parse that. Let's go to our parser. And if we go parse for, let's see that we already have a parser for this. And this occurs, it's a little bit bigger. See, this is within our parse statement, which parses all top-level statements in the language. Right, it's the root of that parser. And we'll say if we encounter a token type, when that happens, token type repeat, we will parse repeat. Obviously, that function doesn't exist yet. That's what we're going to create next, right? It's going to be similar to our for, so let's use that as a starting point. Copy that first line as well and explain it in a few seconds. Right. We'll pause, close that up, and let's clean up the code a little bit here. We pause and repeat. Okay. When we enter this parser, we know that we've reached the repeat token. So we can consume that token because we don't need it anymore. I'll just add little comments here so that as I'm debugging, when I'm stepping through and I see next token, I know what type of token I expect to be skipping past here. Once I've skipped the token, next part after repeat, let's go back and I look at our sample and say, oh, the next thing after repeat is the body. So we need to parse the body of that repeat statement. So we'll say var body equals parse code block. It's a little handy routine I have. Typically, you don't have to pass any arguments to it, but in this case, we're going to need to pass an argument. The reason for that is we're going to create a new scope. That's typical for a code block. So when you go into a for loop or into a function, all those code blocks are new scopes that you can declare local variables within the scope of that statement. We want to do the same with our repeat, but one difference, typically code blocks in ZXN are terminated with the end keyword. So if statement terminated with end, for statement terminated with end, while statement terminated with end, but there are a few exceptions. Like the if statement, I would have if and then else if would actually terminate the previous code block. In the case of repeat, the until is actually the terminator. Right? If we look at this again, the code block runs until we hit the until keyword. So that's what terminates this code block. So we're going to tell our parser that we are going to parse the code body until we hit the until token. At that point, the until token will be consumed already. In other words, no longer available to us, and that's important. We're going to have to work around that in a second or two. But the next thing we have after the body is the, and obviously we've skipped the until, is the actual expression, right? The condition that will terminate this loop. So let's go parse that out. It's easy, it's just parse expression. Now we have almost all the pieces. We've got the condition that'll terminate, we've got the body that we want to iterate. What we need next is to adjust this body so we can include this if statement. Right? In the transformation, we needed to change this condition into this if statement. So let's do that. Right? So var if statement is equal to, and now we're just going to manually create an if AST. Right? Typically, the parser creates these ASTs as it reaches elements, but we're going to manually create an if here that's not really tied to any code, but all of my ASTs do need a root token. So I use that for error reporting. I look at the token that I'm on at the moment, and the token has registered its file and the line and column that it appeared in, and I use that information to report errors. So I do need to tie this if to a root token. If we go back to the code here, it makes most sense that this if is tied to the until keyword, right? Because it's not the actual condition, and the condition gets parsed out, so it'll have the line number and column number tracked appropriately for the I equals 10, but I need something to track for where this if would be, and it really corresponds to this until. So I need the until token. Problem is, I don't have it. It got consumed at parse block. Fortunately, I can say var until token is equal to underscore proof token. Right, so immediately after parsing the code block, I can get the previous token, which will be the until token, and pull that out. That gives me the token for the root of my if statement. Then I need the condition. This condition here is the condition that needs to be true for this if statement to execute. The body, so we'll say condition, which is the condition that we parsed out. It's the line in the back, right? And then what are we going to do? So if we look back at the code in our transformation, if that condition is true, we're going to break. So let's inject a break here. We'll be new break AST. Right? Again, I need a token. What is the break tied to? In this case, the break can be tied to the until token as well, or should I go with the root? I think this is the until token. makes sense. Actually, no. It's better to token, right? Because we're breaking at the point after the conditional expression. Right. Now I've still got little squigglies because this is a statement AST, and we actually need a statement block AST here. Fortunately, all statement ASTs already have a block. Now, because I'm creating a block from the statement, there's a possibility that we might need a new scope. Obviously, we don't in this case. Right? And we will just use the current symbol table. We don't need anything new yet. And that gives us our if statement. I've got a bug here. Token. Sorry, mistake. Until token. Okay. So now we need to get this if statement injected into the body, right? Part of the body of the while loop. We want to put it right at the end. So we can do that quite easily. We just say body dot append the if statement that we generated. Now all that's left is to actually create the while statement that will represent this repeat. So we'll return new while st. Again, I need to tie this while st to a token. And if we look back at the transformation, the while true corresponded to the actual repeat keyword. So I need the token for the repeat word. Let's capture that. When we came in, we knew that the token we were sitting on was the repeat token. Right? That's the one we skipped. So we can capture the current token at the entry point and use that for our while. And then we need a condition. So this while loop, remember we decided that it would need to repeat forever. So I need to put in a Boolean true value there for the condition. So I don't create the Booleans often enough that I feel the need to have a utility function for this. Maybe I should add that, but we'll just create it manually. Yeah. But int st, again, we need to know what token it ties to. This can really just be part of the same repeat, right? And if you want to give it a value, we'll give it a value of 1. That'll be true. And we'll give it a type spec of bool. So that'll tell the compiler that when it compiles this, that is a Boolean, right? And the body that we want the while to iterate over is our body that we parsed earlier. And the coding gods are with us. That should do it. Let's see if this compiles first. Okay, compiled. Let's go see if our test program will work. Remove this while so it doesn't cause any problems for us. In theory, we should see the numbers 0 to 9 printed on the screen. So let's compile code. Okay, it's compiled. We go, yeah, this is generated code. We use trusty old SJSM to assemble that code, and then dezog will run it. And there we go. Worked. Awesome. Stop that and just do a quick test to make sure it really is this code that's running. 9. Okay. Compile that. Compile successfully. Let's run the code. Great. So there you have it. That's what it takes to add a relatively simple construct to the ZXN compiler. Maybe next time we can look at something that actually need new code generation code written. I've got some neat little utility functions that I've put in place that makes that generally quite straightforward to do as well. Obviously more complicated than just a simple AST transformation that we looked at today. I hope you found that interesting, and if there's anything else you'd like to see, let me know. Thanks for your time, and hopefully we'll speak soon.